Hello, everyone. My name is Aaron. I am the AI Program Manager here at Autodesk. I'm going to run through a new addition to the Gameware product middleware group, which is Gameware Cognition. It is a high-level visual programming system for the creation of high-level AI in games. And we're doing something a little bit different this year. We've actually brought all of our middleware together into a common game build with Unreal. And we built a third-person platformer game, which we're showing off at the show. But additionally, we're using that as a common framework to show off all of our different middleware products together. So the role of myself and my team within Hyperspace Madness, which is the game, was to create the high-level AI for this little fellow here, the squid minion. And so I'm going to start off with a short video just explaining where we got to at the end. And then I'll take the rest of the presentation just to discuss how we use the tools to get to the point that we were in the game. So the squid minions, these little fellows down here, they were used in two main ways in the game. The first one was as background characters to provide a kind of a living city feel. And the second was as the primary combat NPC. You can see here that they have two main attacks. The first one is a ranged attack via this laser weapon. And the second one there is that hard melee attack. And I'll die here like I usually do. So before I jump into the making of the squid minion, I want to talk briefly about why it's necessary to have a tool like Cognition in today's game development. And there's three main trends that are really driving the need for high-level AI programming tools. The first one, as many of you, especially in the AAA space, know, the games today are getting much larger. The breadth is much larger than ever before, especially in the AI sense. Specifically, we've got the volume of AI. We've got partner AI in most of the games. We've got our regular NPCs in our games. We've got practice bots to fill out multiplayer games or to provide practice for new players. So we've got that problem. The second one, AI is becoming a differentiator in today's space, especially for the AAA games. And so the AI is expected to be more complex and richer than ever before. So that's making it harder and harder to produce. And those two things are driving the final thing, which is larger production teams. In the old days, not so long ago, there was only one person that was responsible for the entire production of the AI. Maybe 5 years ago, we started seeing more of a split between the design role and the programming role. And today what you'll see is the AI producer. You'll see somebody actually tasked with managing the project itself to produce the AI, and often with the involvement of the QA team. So they come in and they actually can help the other people on the development team with verification of the various pieces of AI. And of course, we've got modders and level designers that also get involved with the game production. So what Cognition is, ultimately, in the highest sense, is it's a visual programming system for the creation of AI. And I'm going to play a short video and talk over kind of how it works at just the highest level. So originally, we developed the concept based on behavior trees, which have been used for years in the AI and other spaces. But through a number of productions in the AAA space, specifically with Red Orchestra, Heroes of Two Stalingrad, and with Deus Ex, Human Revolution, we actually added a lot of functionality relevant specifically to AAA titles that you don't find in basic behavior tree systems. And so we've also developed a fairly rich tool set. So let me discuss just briefly what's happening here. At the base, the real power of the system is that you create AI in many small pieces. So you're assembling pieces that the programmer makes into larger AI, and this allows the designer to really assemble whatever kind of AI they want, and the AI programmer doesn't have to be involved. In the small tree I've created here, essentially, when the player is visible, the minion's going to shoot at him, and when he's not visible, he's going to idle. So we'll just jump right into the game, and you'll see that when he steps out from behind the blocks, he's going to get shot at. So now the AI programmer or the AI designer can go in and they can reassemble all these behaviors into something even more interesting without having to involve the programmer ever again. So now the making of portion of it. So it's over a period of 3 months we made the game, and the AI portion started with the game designer and our team meeting up. And I wrote most fun character ever because that's what every game designer thinks that they're creating for every game. So originally we had a meeting with the designer, and these are very interactive meetings. But really, now that we have a tool that defines and describes the AI, the goal of the meeting, the first meeting with the designer, is essentially to break down his conceptual design into a very specific design, which then the programmer can take away and work on to bring back. And there's no abstraction. I think that's the key thing to take away here, is there's no abstraction between the design and the actual implementation that the programmer will return back to the to the designer. So here was our first iteration, and this is where the producer and the QA department really get involved, is that after this meeting that we had with the designer, we can actually see the various tasks that need to be completed, and because some of the nodes that manage the system come with Cognition, we don't need to worry about everything. We just need to worry about the new ones that were specific to the character we were creating. So we ended up with actually 6 specific tasks at the outset of the game production that then we could parse off and give to the programmer. And this is just, it's great in a sense for project tracking and also QA. So when I get into QA, what the programmer gave back was this unit test gymnasium. And what we have here is essentially every atomic behavior that we created, we just added to this list from left to right, and eventually through the production of the AI, we created a number of behaviors which could be tested individually right here. Now this is particularly powerful for anybody that's ever had to go through regression testing, especially AI, which is extremely complex and touches so many systems it can be broken. Whenever we had an upgrade to the animation system, we just had to come into this gymnasium and rerun each behavior and validate the regressions weren't introduced into the system. So I'm going to, essentially the final tree was significantly more complicated than the one we started with because we ran into a number of edge cases. And the rest of those edge cases we found through gameplay testing. So this is when we integrate all the atomic nodes and all the atomic behaviors into one big tree, and then we play it. And what we're looking for here are 2 things. First of all, we're looking for fun. This is where we decide how frequently behaviors run, how far the minion's allowed to shoot at the player, accuracy, things like that. But we also do with edge cases like this. We didn't know originally that the player was going to be able to fly. So when we had to continually iterate on the system, using an extensible tree-like structure allowed us to continually add new things to deal with the edge cases. And for any AI people in the crowd, you'll know that the AI that you want the player to play is about this big, and the AI to deal with all the edge cases is about this big. So that's really a lot of what's involved in the AI. And the final point, and this is probably the key, and Mustafa from Kynapse is going to come up shortly and talk about this as well, debugging artificial intelligence is really hard. So what we've done is we've developed something we call the AI console, which can connect to remote instances of the game, and it draws out the tree here, and you can actually not only see what's happening in real time, but if anything weird happens, you can actually go back and take a look at it. What I found when we created the minion is that we actually had a failure behavior on the very, at tick 2 at the start of the game, which was odd and indicated there was a problem in the system. So I was actually going to have this fixed, but then I decided it was good for GDC for demonstration purposes, so we didn't. But the main point here is that I was actually able to then just go back to the point that it failed. And in just a few seconds, I can one-click create an AI log, or in this case a snapshot because I'm only interested in that frame, or I could save out the entire gameplay experience, and I can just attach that to a bug report and send it to the programmer to deal with. So there's the ability for the designer to debug things himself, and then there's the ability to report them and communicate them in an actually valuable way to the programmer. So that's the end of the cognition portion. Mustafa from Kynapse is going to come up and talk about how Kynapse was used in the navigation.
There I go. So, welcome back for the second day at the Game Developer Conference. My name is Mustafa Bismi, and I work in the Kynapse Paris team as a senior software engineer. So, I'm sorry for my bad French accent, so I'm hoping that's not going to bore you to death. So, yeah. High-level AI, to perform any kind of high-level AI, you need to rely on low-level services. And this is what Kynapse is about. Kynapse is about helping you, providing you a rock-solid API to perform all your low-level AI SDK. So actually, what is low-level AI? What do I mean when I say low-level AI? What I mean is, the first thing you probably need is to generate some kind of pass data over which you are going to compute pass. And over this pass data, you need to perform path finding. So the ability to compute a path from point A to point B, and then to perform any kind of path following. So you need to control your character, you need to perform steering. And Kynapse will bring you the ability to obviously walk around your environment, but also to be able to use, custom kind of locomotion systems like jumping, doors, teleporters, cover points, any kind of data that you can add on over Kynapse. So Kynapse 2013, well, Kynapse has been released in the industry the first time, like what, 10 years ago. So it has been used in well over 100 games. And it has been used in FPS, MMOs, RPGs, third-person action games. So Kynapse has been really proven. Among all the titles we are going to find Fable 2, Fable 3, DC Universe Online, Homefront, Mafia 2, and so on and so on. So what do we bring new this year? The first thing we bring new is a new feature called the dynamic graph that I'm going to show you today. We bring something called the smooth path system, actually the path refiner, to be able to recompute your path on the fly. We bring optimization and memory footprint. We have added Vita support. We have added Wii U support. You may have heard about that on the web. We provide now full source code access and a new GameWare on Live Dev Center that will help you get support that you need. So what is a nav mesh? Well, a nav mesh is typically used for your local queries, like Querycast. And we use what we call a point graph to perform the high-level queries, like what we call the A*. And the nav mesh and the point graph define what you call the navigatable area. So you can fully control this process, the generation process. You can provide us with your characteristics, like the height and the radius of your characters. You can provide us with volumes to control where you want this data to be generated. And you can use seeds to control where the data is supposed to be, like where are your gameplay areas. So if I show you quickly how the generation is fast and easy to use. So Kynapse generation is fully multi-threaded. If you are working on AI, what you want to do is you want to iterate over your design and your level design. So you want to be able to generate your data really quickly. So for instance, on this level, that is actually a pretty big level, you can generate your data in 5 seconds on just a standard desktop. So it's really fast. And then you can visualize your data and make sure that it is what you want to be, or that you can re-edit it. So Kynapse provides a new system to deal with the dynamic obstacles. So you are probably going to build levels or games design where you are going to have dynamic obstacles falling around on the ground. You want your AI to care about those. You don't want your AI, to make YouTube moments where they are stuck because there is somebody blowing up and then your AI looks stupid. So Kynapse provides you with the dynamic systems that will recompute the path over any kind of dynamic obstacles. So in conjunction with this new dynamic graph system, you are going to be able to see your character navigating around your data and being able to, to find them where, even if they are in a very complicated situation, just like this one, where it has, there is no exit on this way. Never mind. Kynapse will help you find a path really quickly, and you will be able to navigate around all those obstacles. So Kynapse will help you compute and have very natural looks for all your characters. The runtime you provide is really fast, so you can have literally dozens of characters performing pathfinding on a standard level. If you want really big crowd, maybe hundreds of characters, I will turn you to Aaron for population product later on. But Kynapse is already really robust, even on large crowds of characters. So the new path refiner we provide is actually a system that you are going to be able to use with advanced locomotion systems. So if your locomotion system is animation driven, you probably want to compute the best path straight off the box. Kynapse usually computes a really fast path that may not be really good looking. So we use a shortcut system, and you get your character navigating around this path really easily. But now with a new path refiner, you get from the request the path that you can use. That means that you can anticipate over the path. You can reuse your animations, your turn animations. You can anticipate over where and when your entity is going to turn or collide. So, yeah, as Aaron said, debugging AI is really hard. So we provide a tool called Kynapse Lab, where you can inspect your data, make sure that what you fed to us is correct, where you can test your data, make sure that it's correct, the nav mesh is correct, and then you can live connect directly to your application. So for instance, in this little video, I'm going to drag and drop my past data and visualize my nav mesh to make sure that it is actually what I expected. And I can play with this nav mesh. I can perform queries directly in the lab. So you can make sure that the paths are going to be computed in the game. I can inspect my client inputs. So any kind of geometry you give to Kynapse, you can visualize in the lab and to make sure that it is actually the geometry you expected or the geometry you wanted to send to us. So you can check and make sure that it is what you wanted. And finally, the most useful feature for this lab is the ability to live connect to your game. So you can launch your game and then connect to it and record and replay what's happening, visualize where the entity are, where they are going, why they are going the way they are going, why maybe one pass is not what you expected or something. So you can inspect directly your data and visualize it very, very easily. So why use Kynapse 2013? Well, because we French people made it. No, no kidding. Obviously, Kynapse has been production proven in well over 100 titles in every jar. We provide fast, clean nav mesh generation. We provide you with a robust and dynamic pathfinder with a new path refiner feature. We provide you with a mature C++ SDK that is actually optimized for multithreading, I mean SPUs. We provide a full, complete Unreal Engine 3 integration that is actually very, very useful because when you work with Unreal, you really need to move fast usually. We obviously support any kind of platforms. You have the visual tools, and you have us, the support team and the development team that is actually making some supports too. So, well, welcome back. Find out more about Kynapse today at the pod 4 or tomorrow at the pods that are just on your left. And I'm going to leave the place back to Aaron for more details about population, I think.
Yes, absolutely. Thanks, Mustafa. About 5 more minutes. We're going to give you a brief overview of the population middleware product, which rounds out our product offerings in AI. So population, it is a light character system for the creation of living worlds and real-time crowd effects. And when we started developing this product about 4 years ago, really we borrowed heavily from the concept of film extras and what people were doing in the film industry with respect to extras, and that you've got something, a concept that a director can order up 100 extras for a given scene and then direct them as a group. It's relatively inexpensive and it's fast to do. So we really wanted to extend that concept to games, and we did that through the concept of digital extras. And essentially, the level designer can set up levels very quickly and do some really cool real-time crowd effects. Whoops. I want to talk a little bit about the technology before we see the cool demos. So from a design perspective, we came up with a concept of flows, and really those are like sidewalks or conveyor belts that you place in the world, not unlike the convention center here, where the level designer can go in and place out exactly what flow patterns you'd like to see people move in. Mustafa's demo, you saw a lot of minions going in various directions. That was because they were going from arbitrary places to other arbitrary places. In population, as in human movement, people don't walk arbitrarily. They tend to stick to sidewalks or paths. So what we are able to do is set up these nodes and link them together, and then just project extras into the background of scenes and immediately do something very cool and very quick. Also, with respect to the avoidance system, it has knowledge of where the characters are on the flow system and allows them to do very unique things with respect to avoiding earlier on long straight stretches and avoiding later in congested areas. So it's intelligent with respect to density and the type of environments we have. Here's an example of using the tool for an interactive audience. You've got people moving in the background and reacting to game events. But if we look at what the level designer actually had to do, and this is Unreal 3 obviously, in probably a period of maybe 2 hours, this entire scene was set up with various looking different characters, with the animations that were created, and then flows in the background. The final concept are action stations. And level designers can just go in and drop things like this bench here or an ATM or something like that, and the system automatically just draws people off the flows and has them do interesting things. So that's the technology side of things. But really, what we wanted to support was high-level game constructs. And so there's 5 that are typically used in games with population, which was used in EA's Army of Two, the 40th Day, and recently in Tron City for Disney's Tron. And so I'll take you through a couple of examples. So this is a living city. So something like this, as we pointed out in the last level, is relatively quick to set up. It's very performant, very fast. Otherwise, we wouldn't be able to get this many characters on an Xbox or a PlayStation. And you can see there's just the subtle little effects like reacting to the players, being around them. There's lookouts built into the system, so that type of stuff. Now, probably the more fun example would be using extras to give that feeling of being overwhelming forces, the chance that you can't possibly survive. So we use napalm and claymores and the sniper rifle to try to defend our current position. The final example is that of a civilian panic. What we want to show here is some game event that caused them to go from an ambient state to a scared state. And so we'll spawn some bad bots here. They're indiscriminately shooting the crowd, so they are interactive, they have physics. But we're going to make the great shot up the middle to take out the bad guy. So that just gives you a feeling for the kind of ways that population can be used. And that's it for today. That's it for the AI presentation. Thank you very much for your time. Have a great show.